For the last several years, hydrogen discourse has revolved around policy, carbon pricing, subsidies, certification rules, border taxes. The Carbon Border Adjustment Mechanism, or CBAM, became the symbol of hydrogen's future risk. Entire project models were framed around whether Europe would penalize carbon-intensive imports and reward low-carbon alternatives. The assumption was simple: if policy aligns, projects move forward. But Air Products Louisiana hydrogen project quietly breaks that assumption in a way that should force the entire hydrogen sector to pause. When Air Products addressed the status of its Louisiana hydrogen plans, the company did not frame the challenge around CBAM. It did not emphasize uncertainty in European carbon policy. Instead, the message was blunt and revealing. The dominant risk is construction cost, not regulation, not carbon pricing, not certification, construction cost. That single prioritization matters more than most hydrogen headlines in the last year. The Louisiana project was designed to be a flagship hydrogen system. Large-scale hydrogen production, integrated carbon capture, conversion into ammonia, and export to international markets, particularly Europe. On paper, it checks every box policymakers and analysts say hydrogen needs: scale, CCS, export optionality, alignment with decarbonization narratives, strategic geography. If any project should glide through final investment decision on the strength of policy alignment alone, it should be this one. And yet it hasn't. Under the ReneEnergy framework, the first question is never, is this aligned with policy? The first question is always, does this survive system stress? Because real clean tech is not defined by announcements or incentives. It is defined by what still functions when conditions tighten. Under that lens, Air Products Louisiana project becomes a case study in why hydrogen is stalling not at the technology layer, but at the execution layer. This is not a failure of electrolyzers or reformers. It is not a failure of carbon capture chemistry. It is not a failure of hydrogen demand narratives. It is a failure of capital resilience under construction stress. Construction cost inflation has become the silent killer of hydrogen megaprojects. Steel prices, labor shortages, engineering overruns, equipment lead times, financing costs. Each one alone is manageable. Combined, they create a system that becomes brittle long before first hydrogen flows. Air Products is not a fragile company. It has decades of experience building complex industrial systems. If a company of this scale and sophistication is treating FID as conditional on cost containment, that should immediately invalidate the assumption that hydrogen projects fail primarily because of policy uncertainty. Policy risk is real, but it is secondary. Capital risk is existential. From a systems perspective, the Louisiana project reveals why complexity amplifies failure probability. This project is not a single plant. It is a chain of interdependent systems. Hydrogen production sits upstream of carbon capture. Carbon capture depends on compression and transport. CO2 transport depends on storage availability and permitting. Hydrogen feeds ammonia synthesis. Ammonia feeds port infrastructure. Port infrastructure feeds international shipping. Shipping feeds European markets. European markets feed CBAM exposure. Each interface adds cost. Each interface adds execution risk. Each interface compounds delay. In a low-interest rate world, that complexity could be tolerated. In today's capital environment, it cannot. This is why Air Products is not doubling down on political lobbying around CBAM. It is reshaping the project itself. Risk is being shifted. Scope is being narrowed. Portions of the value chain are being discussed with partners. Not because partnership is fashionable, but because capital exposure must be reduced for the project to survive. That behavior is more informative than any press release. Under the ReneEnergy Cleantech test, the core question is brutally simple. If subsidies weaken, prices fall, and utilization misses targets, who is still alive? For the Louisiana project, the answer is conditional. Survival depends not on carbon border policy, but on whether the project can be built within a cost envelope that private capital accepts. This distinction reshapes how hydrogen should be evaluated going forward. The hydrogen sector has spent years debating demand. Who will buy hydrogen? At what price? For which applications? Those questions matter. But the Air Products case shows that even with plausible demand pathways, projects can stall if capital costs outrun economic tolerance. Demand does not save a project that cannot be built. From a time perspective, delays compound risk in non-linear ways. Every year FID slips, financing assumptions change. Interest rates shift, incentive structures evolve, supply chains reprice. Workforce availability fluctuates. Hydrogen projects are not frozen in time while developers wait for clarity. They are exposed to a moving macroeconomic environment that rarely becomes more forgiving. This is why hydrogen megaprojects face a paradox. They are designed to benefit from scale, but scale requires time. And time introduces uncertainty that scale cannot easily absorb. Smaller, modular hydrogen systems behave differently under time stress. They can be phased. They can lock in utilization earlier. They can generate cash flow sooner. They can be financed incrementally. That does not make them glamorous, it makes them resilient. Air Products Louisiana project is not modular by default. It was designed as a large, integrated system. That design choice amplifies the consequences of cost overruns and delays. Once capital costs cross a certain threshold, there is no graceful degradation. The project either proceeds or stalls entirely. This is why the company's language matters so much. When executives say the decision is 99% about construction costs, they are acknowledging that hydrogen's next bottleneck is not ambition. It is bankability. Bankability is where hydrogen hype meets reality. From a space perspective, Louisiana should have been an advantage. Industrial infrastructure exists. Energy resources are abundant. Carbon storage geology is favorable. Ports are nearby. This is not a frontier region experimenting with hydrogen for the first time. If hydrogen struggles here, it will struggle almost everywhere. That does not mean hydrogen has no future, it means only certain hydrogen configurations survive. The projects most likely to move forward are those that minimize system interfaces, lock in utilization before construction, and avoid speculative export dependence. Ports supplying captive industrial users, steel plants with guaranteed offtake, refineries replacing internal hydrogen streams, chemical clusters with shared infrastructure. These systems reduce uncertainty because demand is embedded, not hypothetical. The Louisiana project, by contrast, relies heavily on export logic. Export logic introduces exposure to shipping markets, international policy, currency risk, and geopolitical dynamics. CBAM is part of that exposure, but it is not the dominant risk. It is simply the most visible one. This is where hydrogen commentary often goes wrong. It confuses visibility with importance. CBAM is visible. Construction cost inflation is boring. But boring risks are the ones that kill projects. Air Products' behavior also exposes a deeper truth about the hydrogen transition. The industry is moving from a subsidy-driven narrative to a survival-driven one. Early hydrogen announcements were rewarded with attention. Future hydrogen investments will be rewarded with discipline. The market is no longer paying for vision. It is paying for execution. That shift has consequences for how developers should think. Hydrogen projects must now be designed backwards from bankability, not forwards from ambition. Utilization must be locked before capacity is built. Interfaces must be minimized. Capital stacks must be stress-tested against pessimistic scenarios, not optimistic ones. This is not pessimism, it is realism. The Louisiana case also reframes how policy should be interpreted. Policy alignment is necessary but not sufficient. Governments can reduce risk at the margins, but they cannot compensate for uncontrolled capital costs. Incentives like tax credits help, but they do not erase engineering overruns or supply chain volatility. Hydrogen will not scale because it is politically attractive. It will scale only where it is economically survivable under stress. That is why the ReneEnergy definition of cleantech matters. Cleantech is not technology that reduces emissions in theory. It is technology, systems, and business models that reduce environmental impact and remain economically viable when conditions deteriorate. By that definition, hydrogen is not a monolith. Some hydrogen systems pass the test, others fail. Air Products Louisiana project is not a failure. It is a warning. It shows where the boundaries are tightening. It shows where optimism collides with capital discipline. It shows why the next phase of hydrogen will be quieter, slower, and more selective. And that is a good thing. The hydrogen sector does not need more announcements. It needs fewer failures. It needs projects that reach FID, commissioning, and operation without collapsing under their own weight. This is why understanding system stress matters more than understanding policy headlines. At H2 Hub by ReneEnergy, this is exactly what we focus on. Not technology hype, not political signaling, but the mechanics of survival, where utilization is real, where capital stacks break, where complexity becomes fatal, where simpler systems quietly move forward while megaprojects hesitate. Because in hydrogen, the winners will not be the loudest projects, they will be the ones that survive when capital becomes impatient. Air Products has given the industry an honest signal. Construction cost is the gatekeeper now. Ignore that reality and hydrogen will continue to disappoint. Design around it, and hydrogen can still become an industrial workhorse rather than a policy experiment. The future of hydrogen will not be decided by CBAM alone. It will be decided by whether projects can be built, financed, and operated under real-world stress. That is the lesson hiding in Louisiana.